Today we are talking about combinations and permutations. Just a quick word of warning about this. The math is very easy. The context, figuring out, is this a permutation, is this a combination that I'm looking at? That's going to be the difficult part of these problems. And at first it's not going to feel bad because a lot of these are pre-labeled as a permutation or a combination. So when I go over this and I explain the logic behind it, even though it's already labeled, know that's why I'm doing it. Because when you do these problems on your own, you will need to be able to tell the difference. Let's look at what the difference is between these two problem types. These boxes have the same directions except for one detail at the very end. I'm going to take a closer look at the first one. List the possible combinations of two letters from the letters A, B, C if the order of the letters matters. That's the important information that we need to pay attention to. So we're taking the letters A, B, C and we're grabbing two of them and then putting them in a specific order and listing how many options that would give us. And the order matters. Since the order matters, AB and BA, for example, are different. Since I put them in a different order and I care about the order in this problem, I consider those different answers. Just to really take a look at the difference, we're going to find all of the possible options. So we have AB, BA, and I'll tell you there are 6 total. Again, we're taking the letters A, B, C and making pairs of 2. I've got 2 of them down, 4 to go. Someone throw one out. BC. BC. 3 more. CB. CB. And you're muted. Someone else? CA, thank you.
CB.
We already have CB.
AC.
AC, there you go.
I'm muted.
It's okay. These are all 6 possible ways we can write those letters. 2 letters. Paired up, order matters, so we're trying all possible options here. This is called a permutation. Let's look at the second box. Same problem, but there's one bit of the directions that's different. At the end, it says the order of the letters does not matter, and this does change things. If the orders don't matter, then we will see AB and BA as the same thing. They are the same. They both use the same letters. So if we make our list, I have AB. I will not write down BA because if order does not matter, I will see that as a repeated answer. AC. Got another one? CB, BC, same thing. That's it. If I try to come up with any others, I'm just going to be flipping the letters around, and that would be considered a repeated answer for this problem, since the order does not matter. So I've only got 3 options, and this is referred to as a combination. Reminder, the majority of the problems that you're going to see in this unit, on the test, and the quiz, they will not tell you in the directions. Order matters, order does not matter. That's something you're going to have to figure out based on the information in the problem. Something else I want to point out, because unfortunately this does happen sometimes, and it happened in this problem. Both boxes, the directions ask you to list possible combinations, but the left box, it was a permutation. The right box is a combination. Unfortunately, combinations is a very convenient word to use for these problem types. So just because it directly says combination in the directions, don't assume it's a combination problem. Sometimes that is the case, sometimes it's not. We do try our best to use other words instead of combination, like arrangement or selection, but sometimes combination really is the best word. So just kind of a word of caution there. Make sure you consider if it's a permutation or not. Let's focus on permutations first. NPR, I want you to read that as NPIC-R. I use the word pick here. Pick is the same as permutation. They both use a P. They both start with P. Also, pick kind of has this insinuation that we're being very selective in what we're going to choose, select, grab from whatever the case may be. And again, it's a reminder that order matters. N and R. N is the total number of items. And in the problem, it could be people, it could be things, it could be animals, so items is just a general term. Total number of items to select from. R is the number of items. Being selected. I'm going to show you how to use those in just a moment. But before I do, I'm going to go through a problem and we're going to solve it the same way that we solved these yesterday. Just to kind of give you a little bit of background and to just show you how and why this works. Quick reminder, these first 4 problems are all permutations. You know that because it's in the permutations section. Without me telling you though, I'm sure some of you wouldn't necessarily know without practice. So every time I go through a problem, I'm going to explain why it's a permutation, why the order matters here. So we're thinking about these things. Number 1, how many ways can 5 teams in the National Central League finish in the standings? So we have 5 teams and they're going to be placed 1st through 5th place. It just depends on how they perform. Order absolutely matters here. I think the majority of us in this room, when we are in any kind of competition, we care where we come out in those standings. Obviously, 1st place is our goal. At the very least, we want to avoid being last place. So since it matters to us, the positions usually carry some kind of recognition and reward. It absolutely matters what order things are placed in. I'm going to call these 1st through 5th place. So 1st, 2nd, 3rd, 4th, 5th. Let's say I'm the announcer and I am reading off the teams and what place they got. I'm going to go 1st to 5th. So when I announce the team that got 1st place, I am starting with all 5 teams. Once I name the team that got 1st place, clearly I'm going to have 4 left for the 2nd place position. And just like when we did similar problems to this yesterday, we're going to lose a team every time we go to each position. So it's going to go down until we get to the last team that got 5th place. And just like what we did yesterday, we're going to multiply all these together. That's going to get me 120 ways. I'm going to show you the shortcut on how to do this in the calculator so you don't have to do this every single time. But when your calculator does a permutation, this is the math that it's doing. Just an FYI. So our shortcut. This is what we're going to use NPR for, that notation I showed you a moment ago. First, we need to identify what N and R are in the problem. Still got the definitions above. N is the total number of items that we're selecting from. So we have 5 teams total. Now this doesn't happen often, but we are taking all 5 teams and we're putting them in a position. So we're not choosing a smaller number of them, we're using all of them. R in this case is also 5. Putting it together, plugging it into the notation, we have 5p5. And I'm going to show you how to do this in the calculator. First, let me write down what you're going to press on the screen, or the order that you're going to press things in. For this specific problem, you're going to do 5 first. When I show you where this is in the calculator, you're going to look for NPR, and then the next number, which is a 5. I've got 2 calculators I'll be demonstrating on. My Texas Instruments, my pink calculator. If you have this, most of you have it in blue. And then, of course, the white calculator. So starting with the pink calculator, 5. What you're going to need for this unit is the PRB button. It is right here below the DRG, middle row, second one down. PRB. When you click it, you'll see 3 options, NPR, and CR. We'll use that in a moment. This exclamation point is for factorial. We don't do that in here, so we only need these 2. Since I need the NPR, I'm going to hit enter, the equal sign at the bottom, to put it on my screen. 5 equals, to get my answer, 120, which I do know is correct because I already found it. Questions on this calculator before I show you the other one? If your calculator is completely different from mine, try to find it on your own. And if you can't figure it out, come talk to me afterwards. I'll be happy to take a look at it for you. The white calculator, the button is directly on the itself. You don't have to go into a menu, which is nice. So we have 5. On the white calculator, it's right above my thumb here. I'm going to zoom, or not zoom, focus this just a little bit. NCR, I hope you can all read that. Above it, you'll see NPR. So I'm going to hit Shift, NCR, and it just appears as a P on the screen. Type the other 5. This is 5P5, 120 like it's supposed to be. So it's just as easy regardless of which calculator you use. Questions on either type of calculator that I showed? From here on out, that's how I'm going to solve the problems. They're going to go much quicker. Number 2, how many ways can the top 3 horses finish in a field of 13? The logic, the reasoning behind it is the same as number 1. We have horses. It matters if they get first, second, third, or don't place at all. So order absolutely matters here. Permutation. First we find N and R. We have 13 horses and only 3 are going to place. Putting that together, we have 13, pick 3. And from there, we use our calculator to get the answer. If you type that incorrectly, you will get 1716. 1,716 ways. I'll show you later. For now, I would just practice with this one. You found it? Okay. Number 3. How many ways can 5 cards be selected from a deck of 52 without replacement? Those are the key words here that make this a permutation problem. No, it's a permutation.
Oh, yeah.
Yeah. So, I have a deck of 52 cards. I take one out without replacement. I'm not putting it back. So when I take one card away, I am changing the probability of the other cards being chosen. Because it was 1 in 52, Take a card away, now it's 1 in 51. And that happens every time I take away a card. You change the probability, it's a permutation. If I put the card back, then the probability doesn't change at all. That's why this one is a permutation. By the way, this isn't the only way to solve this problem. I actually could have given you this problem yesterday. So if you prefer how we did it yesterday, you can do that instead. N and R. There are 52 cards, and we are picking 5. 52P5. Calculator to get that answer. This number is quite large. Remember, you will get some large numbers in this unit. 311,875,200. Again, if you're going to use commas, every 3 numbers you put a comma. If you're afraid of making a mistake there, don't use commas. This is 311,875,200 ways. Number 4. How many ways can 10 people line up in a row for theater tickets? Now, some of you may read this and think, well, I don't care which place I am in line. What if the tickets are selling out? You're going to care where you're at in line on top of that. And say someone cuts you in line because they want to get a ticket first. A lot of us care when that happens, myself included. So, absolutely. Huh?
I said we know.
That's okay. That's okay. That's just me. Order absolutely matters. When 2 people switch places in line, that is a completely different line. So this is a permutation. N and R. We have 10 people to choose from. Every person is getting a place in line. So we are picking 10. This is 10P10. Again, sometimes you're going to use the same number twice. Three, 6, 2, 8, 8, 0, 0. Every 3 numbers gets a comma. That's 3,628,800 ways. Questions over permutation before we go on to combination on the back. Combination problems. Couple things. Combination uses the notation in CR. Already kind of previewed that on the calculator. And I want you to think about this or read it as in choose R instead of pick. We're going to use choose. I use the word choose for a couple reasons. Choose and combination both start with a C. Also, when you choose something versus pick just sounds a little more selective. You care a little more about what you're grabbing. Choose, you're just kind of maybe a little more random about it or a little more careless. You grab your items and you go. That's the idea. In combinations, order does not matter. Forgot the order. Order does not, could not care less, does not matter. I think the pizza problem really drives home what a combination problem looks like. You want to make a pizza. There are 15 toppings to choose from, and you decide to select 3. How many different pizzas can you make? Just because I feel like it, I'm going to draw a quick picture. Got my pizza. Let's say my 3 toppings are pepperoni, mushroom. I'm just going to put a couple on here. I'm not great at drawing mushrooms, but I love mushroom on my pizza.
Of course you do.
And then these little bits here I'm drawing on here are sausage. There's my 3 toppings. If I put the mushrooms on before the pepperoni, does that change what type of pizza this is? No. It's still a sausage, mushroom, pepperoni pizza. Doesn't matter what order I put them on. That's what we mean when we say order does not matter. The outcome is still the same pizza. So, order does not matter. It's a combination. N and R. In, we have 15 toppings total, and we're choosing 3. 15C3, 15 choose 3. I'm going to go one time through showing you how to do this on each calculator. For the Texas Instruments calculator, we have 15. Go into the probability menu. I need the next one over, so hit the arrow to the right to put it on NCR. 3. 455 pizzas. White calculator, and this one's actually a tad easier. 15. This time you just hit the NCR button, because that is C, and now it'll be a C on the screen. 3. 455. When you're typing these in, make sure you're choosing the correct thing if you want C or P, because they very much give different answers. So make sure you're typing this in correctly. 455 pizzas. Questions over the calculator, the idea of a combination. Now from here, just again, a little heads up. A lot of students more often than not think that order matters when it doesn't. So typically students struggle to identify the combination problems. So really pay attention as I talk through these. Number 6, a reading list for a course in world literature has 20 books on it. In how many ways can you choose 4 books to read? This one's a bit vague. You could probably go both ways on this, but at the end of the day, when I pick 20 books, it doesn't, out of the 20, when I pick 4, choose 4, it doesn't matter what order I go in. If I choose one first over the other, I'm still going to read the same 4 books. That outcome is unchanged. This is why order doesn't matter, and it's a combination. We have 20 books, and we're choosing 4. So this is 20, choose 4, 20C4. Type that in. And that's 4,845 ways. Number 7, how many ways can you elect 4 candidates to a municipal planning board from a field of 7 candidates? Election type questions come up a lot in this unit for combinations versus permutations, and the context really matters. It would be nice to have a little more information, but based on what's said here, we can safely assume that these 4 people are going to be doing the same job on the board. It didn't say one of them was going to have a leadership position or one of them was going to be president and vice president. They didn't mention anything special. So we have 4, we assume, of the same job. So it doesn't matter who gets chosen first for these positions because they're all doing the same thing. As long as the same 4 people get chosen, doesn't matter. So this is why it's a combination. We have 7 candidates and only 4 will get chosen. So we have 7C4. And there's actually only 35 ways. Last one. Number 8. From a group of 39 people, a jury of 12 is selected. In how many different ways can a jury be selected? The logic here is exactly the same as number 7. We have 12 people. They all have this same responsibility, the same job. They are deciding if someone is guilty or not guilty. That is it. And they all have the same amount of weight to their decision. So again, it doesn't matter what order these 12 are picked. If it's the same 12, regardless of order, it's the same 12 people. Nothing changed. And in R, this is a combination. We have a group of 39 people, and we're only choosing 12 to be on the jury. This is 39 choose 12. Can someone point out what I just did? I flipped the numbers. Notice what my answer is here. It's 0. If you ever flip the numbers, you will never get an answer of 0 on any problem we give you. So if you end up with a problem with 0, with an answer of 0, a mistake has been made. Just a heads up, because this will happen. Someone will do it. Never write down 0 for any of these. It's not possible. So that's a dead giveaway that the numbers are in the wrong order. So flip them if you ever do that. Also, if you haven't noticed, every problem we've done, it's always been bigger number first, then the smaller number. That's not by coincidence. That's what always happens. This number is quite large. It's our largest yet. 391,079,7436. This is 3,910,797,436 ways. And that's just combinations. Permutations would be ridiculous. Questions over combinations before we get to the unknown problems. All right, like I said, the math is not hard. Deciding permutation, combination, that's what makes these difficult. So these 3 problems, this is what you'll be expected to do on a test or a quiz. Here's a problem, figure out, is it combination, permutation, and then you're gonna do the math. I'm not gonna do the math on this one. We're just going to answer combination or permutation. What I'm gonna do is I'm gonna read through it, let you think about it for a moment, and then we'll discuss which one it is. We're gonna do this one at a time. First problem, suppose that you would like to test 3 of the 10 laundry detergents at the store. How many ways can these be selected? So if you select your 3 laundry detergents, does the order matter? Think to that to yourself for a moment, please. I'm going to read it again. Suppose that you would like to test 3 of the 10 laundry detergents at the store. How many ways can these be selected? If you're ever stuck, you can't figure out, you can't go one way or the other, here's a great strategy. Come up with an example. So 3 laundry detergents, we can probably come up with 3. I go to the store, I pick out 3 laundry detergents. Tide comes to mind, so let's pick up a thing of Tide. Let's pick up a thing of OxyClean. And then I personally like to use Gain, so I'm going to put that down. Say I pick these 3. Now again, the question is, does order matter? So if I change 2 of the positions, let's see. Let's say I pick up the Gain first, and then the Tide, and then the OxyClean. So I changed the order. Did I still walk out with the same 3 detergents? Absolutely. It didn't change a dang thing. It doesn't matter what order I picked up those 3 detergents in. So order does not matter. This is a combination. Second problem. An employer must choose 4 equally qualified applicants from a pool of 15. How many ways can the 4 applicants be chosen? Think about it for a moment, please. There are 2 words in here that give it away. An employer must choose 4 equally qualified applicants from a pool of 15. So there really isn't one advantage that one has over the other. On top of that, again, some extra context would be nice, but we're kind of under the impression they're all going for the same job. So we have 4 job positions open, all equally qualified candidates. So we're assuming same job, same responsibilities, and more importantly, same pay. There isn't a benefit to one being chosen over the other. Again, order does not matter here. Combination. When there's some level of equality in the problem, it's typically a combination. When there's a permutation, there's some consequence to changing the order. Last problem, this is a classic one, you're going to see it a lot. A president, secretary, and treasurer will be selected from a committee of 17 people. How many ways can this be done? We have 3 positions, president, secretary, and treasurer. Only one person can get each position. On top of that, each position has different responsibilities and more than likely different pay. So you're going to care, if you're applying for these 3, you're going to care which one you're going to get. So absolutely, order matters here. This one is different responsibilities, or different positions, I should say. Put both down. Different positions / responsibilities. And only one person can get each position. It's not like we can put everyone as a president or as a secretary. When you have different positions, order matters. This one is a permutation.